see my screen.
You're good.
All
Whenever
right,
you're
awesome.
ready.
Well, let me first and foremost thank Tracy and the rest of the Holden team for hosting us, allowing us to present today. I'm excited to see as many participants as we have on the line, 90 people. So that excites me because that means that there's somebody else that's interested in kitchen ventilation other than myself and Felipe, right? So glad that you guys could join us. Just to let you know obviously who we are, I've got about 20 years of experience in kitchen ventilation. Used to work for one of the other hood manufacturers in the business. And so I'm a graduate of Georgia Tech. I have a mechanical engineering background. So again, we're able to speak the language. And that's one of the most important things that I feel is communication, right? Being able to speak to engineers and people that understand what engineering minds and how we think, right? So Felipe has also been in the kitchen ventilation or the ventilation business 8 to 10 years, roughly. Is that correct? Okay. And again, we're the representatives for the entire state of Georgia. So hopefully, if you guys have any questions down the road, we do work through Holden as a partner, as part of the GreenHeck family, which we'll talk about here in a second. But we do cover the entire state of Georgia. So hopefully we'll have an opportunity to meet you guys in person at some point. So some of the things we're going to call basically as an overview talk about today is who is Accurex, right? For those who have not heard of us or worked with us, what's new in kitchen ventilation? What do you need to know to design or implement a kitchen system? And how can Accurex be the easy button, right? I mean, that's really our goal as a manufacturer's rep is to see how we can help you and take that burden off of the responsibility of designing a kitchen ventilation system and being that easy button where you can just give us a call or go through Holden rather, to send in a request and we can turn around a pretty quick selection for you guys or answer any questions that you may have that you may not be aware of. So as I said, we're part of the GreenHeck company. And how I like to describe it is Accurex was formed to really focus on kitchen ventilation. We know GreenHeck offers an entire line along with the other business units that they offer and have partnered with. But Accurex is solely responsible for kitchen ventilation products. We don't deal with bathroom fans and things like that. We do have some access to smaller fans, but we're not looking to design outside of the kitchen, really. So if you do have any other questions, obviously, like I said, Holden would be your support. But when it comes to kitchen ventilation systems, that would certainly be us. We know your time is valuable, right? As engineers, we know you have a great responsibility of designing other aspects of the buildings. And so, as again, I said before, we want to be that easy button where we know we can turn around drawings within 24 to 48 hours and get you guys on your way with the rest of the design and having to do it once. Obviously, we know there's changes on certain jobs, but we want to make sure that we're designing it properly the first time and that you're not questioning or having to come back to us for additional changes and things like that because we've done something wrong. So again, we want to make sure that we're doing things the first time. We do work in AutoCAD. We do have Revit files available as well. So we're trying to stay up to date with some of the most current technology when it comes to designing as well. So if you have any questions about that, like I said, we'll be glad to help you out. As far as support, I'll twist this because designing a product is one thing, but once we've sold it, you want to make sure that you have a sustainable product that can be supported in the field. And so we do have not only online tech support or 800 number that you can call 24 hours a day. We do have an 18-month warranty period of all of our products. We could do extended warranties as well, but our standard is 18 months. But we also have field technicians that we label as factory authorized service companies. So oftentimes we'll send local mechanical companies or HVAC companies that will go to training in GreenHeck in Wisconsin to do training so that when they come back to Georgia or any state for that matter, they can service our products knowing that they've been trained specifically to work on them. So you do have a product that we're selling that can be supported no matter where it's sold. Here's just a list of all the things. And really, I like to just sum it up by saying if it's related to a kitchen hood or kitchen ventilation, we supply it, with the exception of makeup air duct. So you can see the entire list here. We're not going to focus on every specific product, but definitely want to let you know that we do offer the entire package because most manufacturers, if you think about it, except for one competitor, only offers hoods. They don't offer fans. And that's a real big selling point for us because if there's an issue, we deal with this especially when the food service designer specifies the hoods, and as an engineer, you may specify the fans. There always ends up being this finger pointing situation where who's responsible if the hood doesn't work. And so for us, if we're able to sell the hood and the fans, it allows us to have a lot more control and responsibility over any issues that may come up in the field, specifically when it comes to even wiring the fans directly to the controls in the hood, which is always a big pain, when you do have those systems split up. So again, we'll dig into some of this, and we do have some items at the end that we can certainly get into later on and maybe meet either online or in person to talk about later on. So we all know that codes drive what we do on a daily basis. For us, when it comes to kitchen ventilation, Our major focus is IMC, and as you all know, if you're in Georgia, we did finally jump up to 2018, even though we're 7 years behind when it comes to the mechanical code. But we are using the latest version of NFPA 96 and 101, which are more for fire protection as well as fire safety. Now, one of the things about Georgia, if you're not aware, the Department of Community Affairs has an amendment that is applied to the mechanical code, specifically when it comes to kitchen hoods that we deal with. And basically what they've done is they've taken the 507.1, which is just the introductory paragraph of the code, and saying that it's been substituted with the current nomenclature that you see here, which essentially says anything within that first section is null and void, and we're going to follow NFPA 96 as well as Life Safety Code 101. So really that's kind of the basis. Now you can go above and beyond, or at least the inspectors can always go above and beyond these two codes. But for the most part, again, we're going to follow IMC 2018 and these two codes as well. And I know you're probably saying, well, why should I be concerned about the amendments to the code? Well, if you look at 507.1, this was something that a lot of UL listed manufacturers lean on, is because there is an exception in there that allows them to bypass a lot of the basic requirements for a kitchen hood. Most of the ones that you see in red at the bottom are more about the construction of the hood. And even for type 2 hoods, there's some construction details in there. But the most important one on here is 507.5, which deals with how we determine our airflows for our kitchen hood. And we'll talk a little bit about that when we get to our exhaust fans and how we determine that. But again, just as an FYI, section 507.1 has been amended out of the Georgia code. And again, it's up to the local inspector to actually follow or meet that requirement as well. So where does that leave us? Well, as a UL listed manufacturer, if you go back to NFPA 96, which is the minimum requirement, there is a section in 5.4 that says that basically we're able to follow the installation based on our UL 710 testing. So that's another reason why it's important for us to specify UL listed, or even for that matter, just listed products, because we know it's been tested to a certain standard. So that UL 710, which applies to grease-laden hoods, is very important for us because, again, it allows us to navigate around some of the requirements of some of the codes as well. So what are some design considerations? Well, for us as designers, the main thing we always look at is the equipment. That's going to start our design process and help us identify what type of hood we need, how much airflow we need to exhaust. And from there, obviously, the design rolls on. But the most important thing we're always asking our customers, what are we covering? Because in some cases, you may not even need a kitchen hood based on the light duty appliance or whether or not it's actually producing any effluent at all. It becomes a real gray area, especially when you're dealing with electric ovens. If they're only baking in it, some jurisdictions don't allow or don't make them require a kitchen hood. So again, the most important question we always ask is what are we covering, and that starts the process for designing a hood system. Now, when it comes to types of hoods, there are only two types. There's actually three, but in this case, when it comes to kitchen ventilation, we tend to focus on two. The first one I want to talk about, and we'll just get it out the way, is a type 2 hood, which is for either heat or condensation only removal. Normally, you're going to see a type 2 hood over dishwashers or, like I said, some electric ovens that are only producing heat. And the great thing about that is it's basically a stainless steel box. You have an opening at the top where you're going to exhaust. There's no need for any fire suppression system, no filters. It's the most basic hood system you can think of. Now, what we're going to focus on today is going to be our type 1 hoods, where it's a little bit more involved. Obviously, you have to have grease filters that remove grease from the airstream. You have to have a fire suppression system because you are producing grease. It becomes a fire hazard. You have to have welded duct, so on and so on. There's a lot more required for type 1 hoods than the type 2 hood. Again, that's why it goes back to the conversation of what are we covering. And then we step from a type 1 hood, which is standard grease, but you also have a type 1 hood that can be used for solid fuel. That case, what we'll end up doing is building in what we call spark arrestor filters, which essentially stop the embers from the cooking process from getting in the duct and causing a fire. But we also end up running at an extremely higher exhaust rate because we're dealing with higher temperatures and more effluent, which is basically the product of combustion from the cooking process that will be exhausted. As again, I said, fire suppression is required on all type 1 hoods. And let me kind of go back when we discuss type 1 and type 2 hoods. You can put a type 1 hood over a appliance that requires a type 2 hood, but you can't put a type 2 hood over a type 1 grease application appliance. So again, you can actually put a type 1 hood over an oven, and the local fire marshal may not require a fire suppression system, but in most cases, from my experience, if they're going to have grease filters and grease duct, they're probably going to push to have a fire suppression system built into the system as well. So again, most of our fire suppression systems are going to be UL 300 listed. And basically, obviously, the purpose of a fire suppression is to prevent that fire from spreading from under the hood into the grease duct and as well as the rest of the building. So most of our type 1 hoods, like I said, will have a UL system. When it comes to fire suppression, you do have two different applications. The first one is what we call appliance specific. And what that means is we're going to take the customer's appliance layout based on where the appliance is and the type of appliance it is and the cooking surface. And we're going to put dedicated nozzles over that appliance based on how either Ansel or whatever brand we're using requires us to cover it. As you can see in that lower picture down there, like I said, it's going to have a spray pattern that's going to spray the appropriate amount of chemical to suppress the fire suppression system. From there, you can go to a little bit more expensive option, especially if you're dealing with a situation where you have a test kitchen or even a school that's going to change appliances frequently. The overlapping protection coverage is going to be used where you have basically nozzles every 12 to 14 inches, and you don't have to worry about changing the nozzles if they change the appliances out, because it has a coverage that covers the entire space, not just the cooking surface of the appliance. Now, again, it's a little bit more expensive because you're using a little bit more chemical, and you're probably going to have a lot more nozzles inside the hood. But again, if you have a ghost kitchen or, like I said, a test kitchen that's going to be changing appliances on a regular basis, this is something that they may want to consider to minimize their long-term costs when it comes to modifying the fire suppression system. One of the accessories, obviously, in a Type 1 hood is going to be the grease filters. And there are multiple stages, not just within Accurex, but most hood manufacturers have different stages of grease filtration. Your average filter captures about 28 to 30% of the grease. And it's pretty much the standard in most kitchen hoods. However, if you're dealing with an application where you know there's going to be a lot of grease-laden vapor or grease content in general, such as a high-end burger restaurant or even a Chinese restaurant that does a lot of Asian cooking with fatty foods, you may want to consider going to a more efficient filter so that you're capturing more grease at the hood versus allowing that grease to collect inside the grease duct as well as the fan on the roof. So the last stage would be what we call our grease grabber filter, which is our most efficient filter, which is great in theory. But I always point out the fact that if we're going to consider going to something like this, that we consider the static pressure in the grease duct, because the more efficient the filter is, the higher the resistance is going across the filter. But then you also have to think about the long-term effects of the staff cleaning these filters. Now, all of our filters are dishwasher safe, but I don't know about you, but when I worked at a restaurant when I was in high school, the last thing I was worried about is how often I was cleaning the filters. So again, most restaurants and the staff really have to be trained to understand that if you have a more efficient filter, you're going to also have to clean it more frequently. So they have to be thinking about that because when these filters do collect more grease over time, as that grease hardens, you get less efficiency out of it as well. So normally we're either going to go with the basic filter or the middle of the road extractor filter for a little bit more higher efficiency. Now, when it comes to actually designing the hood itself, once we have all these characteristics identified as far as the cooking appliance itself, we get more information about the space, the constraints of maybe the ceiling height, things like that. That would help us determine what style of hood that we're going to use. We already know we're going to need a Type 1 hood, which is going to collect grease, but we have various applications when it comes to hoods. Couple applications here going from left to right. Your most basic application is going to be called a wall canopy, where you literally will have a wall right behind the hood system. But oftentimes you may find yourself, especially in a school situation, you may have a situation where you have two hoods or an island configuration where the appliances are in the middle of the kitchen. And we would need either a back-to-back hood system, as we see second here, or a single island hood if you have a single cook line. And again, the biggest difference between the two island hoods here is the fact that you have either a single cook line or you have a double cook line where they're back-to-back. And that's when you would obviously use a double island hood. Now, the last option we have on the right is, we've all been to my favorite restaurant, right? The Waffle House, where you're looking for a smaller footprint, or you just have limited space to the ceiling. You might want to go with a low proximity hood, which does capture a little bit better because it's closer to the cooking surface. So in most cases, we can run that at a lower exhaust rate. Now, again, sometimes, like I said, because it is hung at a lower height, that can be an issue for some of the staff that's working in the kitchen. So we really want to look at the constraints of the space to consider using something like that before we make a decision. Again, going back to IMC, Section 5074 talks about the hood sizing. And just keep in mind, when we're talking about sizing the hood has to be bigger, or longer rather, than the actual cooking appliances. Anybody remember dealing with fluid dynamics? The idea is basically when you have a hot or a heat source, especially gas, what happens is it tends to rise and expand, which is the reason why code requires that we have at least a minimum, and I'm going to stress that, a minimum of 6-inch overhang, which means we have an additional 6 inches to the left and right, or even the front in some cases, beyond the actual size of the cooking surface. So this basic example that I've drawn up is basically an 8-foot cook line. And if we look at the required overhang on the sides, we know we need to add 6 inches to that overall length. So theoretically, the minimum size hood that we can use per code is going to be a 9-foot hood. And again, we do take into consideration the depth of the hood as well, where basically if we're considering 6 or 8 inches of space behind the appliances, because you do have gas connections and electrical connections, and we know you're not going to be able to put the appliances flush against the back wall, we know we need to account for that space as well as additional space in front of the appliance. Our standard right now has been a 54-inch deep hood, but obviously if you have deeper appliances or heavier duty appliances, we're going to push that extended from 12 inches of overhang, or 6-inch overhang to possibly 12 or even 8-10 in some cases of overhang. Other things that we want to consider as we're looking at this is which you can't see with the naked eye, right? Like I said, the gas tends to rise and expand, and this is just a visual representation of what they call a Schlering image, which is basically a camera that's able to see the heat, kind of like if you were out on a hot summer day and looking at the road, you would see kind of that wavy mirage, as we used to call it. Well, this is a way that they're able to determine spillage from appliances that you wouldn't be able to see with the naked eye. And as you can see, just going left to right, the 6-inch hood or 6-inch overhang that we have on the left is allowing the heat to spill into the room versus going to a 12 or even 18-inch overhang where we're able to capture a lot of that effluent that's coming off the appliance. So again, that's the reason why overhang is going to be really critical when we're talking about designing a hood, because we don't want that effluent to spill into the kitchen space or create a load on your HVAC system. Again, looking at appliances, normally they're rated based on what we call the duty, which is usually the cooking surface. So light duty appliances obviously are going to be your lower temperature appliances, or they're not going to create as much heat externally because it's all internal due to the cooking process. So ovens, most of your heat's going to be contained inside the unit until you open the door, but they're still considered light duty. As we move down the chart, medium and heavy and extra heavy duty, obviously is going to be based on not only the cooking surface, but again, what type of food are you going to be cooking on the appliance itself? So we're going to look at some of that as we talk about, again, some design considerations. And you'll hear me refer to light, medium, and heavy duty appliances in that manner based on the cooking appliance itself. So if we're talking about overhang, as I mentioned before, 6 is the minimum. But these are some basic requirements that we recommend when it comes to designing a hood. And obviously, again, talking about space constraints, we may have to change some of these numbers. But in most cases, if we have the space, we're going to try to maximize our overhang so that we can capture as much of that effluent as possible. So for a charbroiler being heavy duty, we're going to recommend 18 to 24 inches of overhang on the front side and 12 inches on the side of the appliance if indeed it is on the far left or far right of the cook line. Now, if it's in the middle, we're only considering overhang from the end of the cook line, not the middle of the cook line. Fryers are a little bit lighter duty, so they're represented by the medium duty selection. So we're going to recommend 12 inches of overhang on the front and 6 to 12 inches of overhang on the side, depending on the size of the griddle and the number of fryers that we may have. Conveyor ovens are kind of a tricky application because most people look at them and say, well, most of the heat is still contained inside of a conveyor style oven. If you've ever been to a Papa John's or I know Uncle Mattio's was a big pizza concept here in Georgia where you can see them actually cook your pizza, you would see that they would put most of the room temperature ingredients on one side, and as it cooked through the oven, it would come out and also be smoldering hot. Well, you still want to capture some of that grease-laden vapor that's coming off the food as it comes out. So our recommendation is, because the cooking is done from left to right or even right to left in some situations, we want to put 6-inch overhang on the front side of the oven, but 12 inches beyond the actual conveyor. Because again, depending on which direction it's going, we want to make sure that we're completely capturing the effluent off the appliance. Convection ovens, again, because the front door tends to hold the heat is maintained inside the unit. When you open that front door, we want to capture as much of that heat that spills out when you're pulling it, because it also pulls a lot of that heat out from inside the oven and pulls it towards the cook. We want to recommend at least 24-inch overhang when it comes to the front of that unit. And because the sides are not exposed on the oven, we're going to recommend at least 6 inches. And of course, based on dishwashers, Depending on this, if it's a conveyor style or a standard dishwasher, we're going to recommend 12-inch overhang on the front. And again, if it's a conveyor, 24 inches on the sides. Another consideration we look at is not only the left and right dimension of the hood and the front to back dimension, but the height of the hood. And oftentimes this plays into the duty level of the hood, where certainly when we get into a heavy duty or even solid fuel cooking, we're going to recommend raising the height of the hood so we have more capture volume. Because if you've ever seen a hood perform, you're not going to get 100% capture on the first pass through as the effluent passes across the filters the first time. Normally what's going to happen is it's going to pass through the filters, and what doesn't get sucked out through the filter is going to recirculate inside the hood. So we consider that capture and containment. So by increasing the height of the hood, we want to make sure that we're containing that effluent inside the hood so that it gives it a chance to roll around and then eventually go back out through the filters. Again, we normally reserve these taller hoods for heavy duty applications, and again, extreme heavy duty applications as well. We also look at the environment around the kitchen hood. We know these kitchens aren't going to be inside of a perfect environment where you're not going to have any cooks working inside the kitchen. There's not going to be diffusers and things like that. This all plays into how we design a kitchen hood. So whether there's a doorway on the side of the hood or a pass-through window or even a diffuser, which we'll talk about in a second, we're trying to make sure that we're building in a safety factor when it comes to airflows. And so options that we have as far as accessories are what we call end panels that allows that effluent to be contained again. Capture and containment is important. That allows that effluent to stay inside of the hood area instead of spilling out. But it also allows us to suck directly in front of the appliance as opposed to pulling from the sides. So it does allow us to reduce the effectiveness, reduce the cross paths that may happen inside of a kitchen from somebody simply just walking across the cook line. And these end panels are pretty effective in two different options. We can either do a full panel, as you can see on the left, or we can do what we call a mini or quarter panel that is just as effective because, again, you're focusing the exhaust drafting in front as opposed to the side of the hood. We talked about this exception that I brought up at the beginning of the presentation. And again, airflows being 507.5 is where that exception, when it was pulled out, kind of had a lot of questionable thoughts from some of the inspectors because they didn't know how to interpret this code. Well, 507.5 focuses on how much exhaust we're taking out. And again, if you look at the IMC values when it comes to exhaust, they're much higher than what we see from our UL listing. And again, because we've tested it in an environment where we can look at light duty, medium duty, and extra heavy, heavy and extra heavy duty appliances, we can determine which airflows work best in that situation. So if we're looking at this chart, IMC recommends for medium duty 300 CFM a foot. And essentially, if you had a 10-foot hood, that would be 3,000 CFM. Heavy duty, you're looking at 400 CFM a foot. And then, of course, extra heavy duty, you're looking at 550 CFM a foot. And again, because we have a UL listed hood and it's tested to the UL 710 standard, we're able to actually reduce at a minimum of 135 CFM for medium duty, 197 for heavy duty, and then 240 for extra heavy duty. Now, I know you're probably looking at the bottom of the chart saying, well, why are you saying that your typical airflow is a little bit higher? Again, we know we're not designing for a perfect environment. If you've ever seen or have not seen the UL testing, literally they will put the appliance in the room, close the door with the hood, and turn it on. We know that's not how a kitchen operates in a normal condition. So again, considering cross drafts and other factors inside of the kitchen, air conditioning, things like that, we know that we're going to have to probably pull a little bit more air. And from our real world experience, we're going to recommend for medium duty at least 200 CFM a foot, heavy duty 275, and of course, extra heavy, a minimum of 350. These are all considerations, like I said, we can evaluate, some situations as we get to, into this DOAS applications, we're able to reduce those airflows. But again, these are typical airflows that we know work from real world experience that we don't have to, think about once we have a hood in the field, it's been installed. Now we've kind of talked about exhaust rates. Obviously, we need a fan that's going to be able to exhaust. And most of the engineers on here, again, probably are familiar with green hex, so we're not going to jump too far into fans, but just know that there are multiple applications that we use for exhausting, whether it's a roof mount fan that you see on the far left, which is I would say our fan that we use 90% of the time. But oftentimes we do have applications where we're going up a chase or we need a little bit more airflow for multiple hoods. Sometimes we'll use a utility set fan. And of course, obviously, if we can't get to a roof, we'll have to use an inline fan in order to discharge out the side of the building. Now, one of the things I do want to talk about is the fact that we are moving away from belt drive fans, just like most manufacturers. And so we're normally going to recommend either our very green motors or induction direct drive motors. But the benefits obviously is that we're eliminating any sustainability issues when it comes to belts and pulleys. We're often using VFDs that will allow a slow ramp to preserve the life of the motor. But in the long run, the very green or VG style motors that we're using are more efficient and easier to balance in the field. If you haven't dealt with these before, we're typically running power directly to the fan to basically power the motor, but they're often using a 0 to 10 volt signal from our control panel that we'll talk about in a second in order to control the speed from the control panel that is attached to the hood. So one of the things that we just released is our new power packs. In the past, people were a little wary about using VG fans or very green style fans because you basically had to disassemble the entire fan to replace the motor. Well, now that we have these power packs, essentially we have 4 bolts that holds the entire assembly together. You unbolt those, pull the entire blower and motor out, and you replace it with a brand new power pack. As you can see here, we're 72% faster in service compared to the previous design. And this is now available, has been available, I think, for the last 3 months with most of our very green style fans. So hopefully, again, on the mechanical side, when they're installing it and servicing it, this will be a big help for them. Just a couple of code requirements I just want to touch upon real quick when it comes to exhaust fans. The bare minimum as far as the discharge height from a roof, if you're dealing with a roof mount fan, has to be at least 40 inches. So normally we'll vary the size of the curb, which is a support mechanism that sits on the roof and the fan sits on top of that. We'll vary the size of that to make sure that we meet that 40-inch requirement by code. If you are discharging out the side of the building, just know that you can't be within 3 feet of any exterior openings, whether it's a doorway, a operable window, or any makeup air unit. I believe NFPA has a section in there that kind of determines how much further it needs to be away from there. But as far as the location of the exhaust and makeup air, you have to be 10 feet away so that you're not bringing in any exhaust back into the building. And of course, if you are wall mounting, it does have to be at least 10 feet above grade. So that's always a consideration if you're going to be mounting the unit on the outside of the building. Once we determine the exhaust rate, normally the next fan we're looking at is makeup air because we have to find a way to, of course, balance the building. That is truly the most important part of the makeup air is in its name, right? Making up the air that we're exhausting. And I often show this picture because people have been to restaurants where you even have either seen this sign or if you tried to pull on the door, it's extremely hard to open. And the reason that is because the space is severely under pressurized. And so you have too much exhaust and not enough makeup air. Now, we run into this basically in various areas where if they decided they didn't want to temper the air, they'll turn it off in the summertime or even in the wintertime in some cases, and just didn't realize how much that's affecting the space as far as the pressure and, of course, the performance of the hood system as well. But again, just want to point out the whole purpose of makeup air is to balance the entire space or balance the amount of exhaust that's being exhausted through the kitchen hood. Here's a traditional representation of how a kitchen is set up, right? You have your, and I don't know if you can see my cursor here or not, but you have your exhaust on the far right with the red coloring, where basically we're taking air out of the building. Your makeup air unit is bringing fresh air back in. And generally a rule of thumb for us is probably 80%. So if we're exhausting 1,000 CFM through the exhaust fan, we're typically going to recommend bringing in about 800 CFM of makeup air. And then, of course, that additional 20% is made up through the rooftop unit where we're recirculating some of that fresh air back into the space. And again, I know that mindset has kind of changed over the years as we start talking about comfortability inside the kitchen, and we'll talk about that a little bit. But this is our base, when it comes to a kitchen ventilation design. We normally don't get involved in the rooftop unit, again, because we're focused on just the kitchen hood system. So we're going to start with just an exhaust fan and makeup air. And what does code say about makeup air? Well, the key thing, obviously, it's required, but I've highlighted here that makeup air shall not reduce the effectiveness of the exhaust system. And you're probably questioning, what does that mean? Well, not only is it important that you have makeup air, but how you introduce makeup air is just as important. And I'm sure if you've been in this business a long time, then you've seen a number of options when it comes to integrated makeup air. I've pulled out some of the most recent ones that we've probably seen when it comes to the latest designs. But I want to kind of point out that most of these they will work in just about any condition if you design it properly. But the reason why the first two that we see on our screen going left to right are probably not preferred, or you're starting to see less and less of them, is because of how they're being designed. Replacement air, like I said, is important. But if you're talking about short circuit hoods, which is the first one we're going to talk about, the reason why you've seen them kind of go the way of the dodo, if you will, as an extinct option, is because you're introducing too much makeup air on the inside of the hood, right? You're trying to exhaust and introduce air inside the hood versus allowing it to naturally draw in. If you look at the IECC, it actually says that you're not even allowed to bring in more than 10% of makeup air inside the hood. And there are various states like Kentucky and Minnesota that actually have prohibited the use of short circuit hoods. However, again, it's always open to the local jurisdiction to determine whether or not that is something that can be used. But I want to show you a quick video. And before I play the video, just explain what's going on. So this is the video that we had. It wasn't one of our hoods, by the way. I always throw that out there. But this is a video of an existing hood where the makeup air is actually on the left video. And then we had the installer turn the makeup air off on the right side. And you see how much better it performs because we're not introducing as much outside air inside the hood, which is blocking the effluent from escaping through the filters because that air is being introduced directly at the filter itself. So let me show this real quick. And you can see, like I said, how turbulent that air is as it reaches the bottom of the hood because that's where makeup air is being introduced. Versus on the right, where there's no makeup air at all, you'll see that that air is just naturally drafting into the filters as it should be. Now, you probably saw the smoke move a little bit on the left video because they pressurized the room by opening the door. And so that did change. And again, that's why that's important to think about all these other things involved outside of just the hood and the appliance, because opening a door or opening a window change the pressure inside the space. Another option that I've seen specified and was kind of big, especially back in the early 2000s, was the back supply plenum or back return plenum. And in this video, what you'll see is, well, let me go back to the theory first. The theory was the outside air would be introduced under the appliance and basically roll around the appliance and naturally draw back into the hood. Well, a lot of customers were complaining because their kitchens became extremely hot. And we were trying to figure out why. So I had a contractor go out to a job site. This is actually at a Longhorn Steakhouse, a reputable company, a restaurant. And we had them put smoke bombs inside the makeup air fan to illustrate where that air actually travels as it comes inside of the kitchen. So the kitchen's not on fire, but we're just, like I say, illustrating where that smoke is or that air is going by visually seeing where the smoke is going. And you see a lot of that air spill directly into the space as opposed to recirculating back inside the kitchen, which was kind of the theory. So a lot of engineers and contractors were saying the back return was a great option because if you were up north, he's talking to my end, so you guys hear that. But in theory, the air didn't have to be tempered because it was being introduced under the appliance, and the staff didn't feel it as much. Well, again, even if it was cold air, you're now dumping a lot of that cold air directly into the kitchen space. And of course, if it's hot outside, a lot of that humid air is going into the kitchen space as well. And what happens? Obviously, now you got to increase your HVAC output to offset that humid air that's coming inside the space. So finally, the option that you'll see a lot of manufacturers using now, not only us, but most of our competitors, is what we call a air curtain supply or a front supply plenum, right? Which basically is an accessory on the outside of the hood system and allows that air to naturally fall in and go right back out through the hood because it's introduced closely to the hood system itself. Some of the benefits of this obviously is making sure that we have the right velocity, because once your velocity gets above a certain limit, then it becomes too turbulent and it doesn't go inside the hood. And of course, if it's not fast enough, then most of that air is going to diffuse to the space. But the benefit is if you're in between that range of 140 to 160, that air just naturally draws in the bottom lip of the hood and goes right back out to the hood with a high percentage of exhaust. Now, 100% of the air doesn't go directly to the hood. We know that there's going to be some diffusion, but in order to minimize that, we've got to make sure that the velocity discharge is within that certain range so that we're capturing as much of that outside air, especially if you're not tempering it, exhausting that out directly back through the hood. Typically, this plenum and multiple manufacturers design this a little bit different depending on the output, but most of the plenums are between 18 to 24 inches above the hood. Because again, we want to make sure that it's not being distributed directly on top of the staff if they're standing right underneath the hood. So having it at a higher discharge point often helps in that manner, but it also creates a lot of positive pressure. I don't know if I can have a cursor here. I don't see it. Creates a positive pressure at the front lip of the hood, and it prevents the effluent from spilling out because of that positive pressure. Well, again, most of the major manufacturers are using this technology now. And of course, the good old ceiling diffuser, right? I mean, as you see in this picture, Ceiling diffusers are great for conditioning the space, but as you can see in this picture, they're probably not in the best location. Most of the drawings that we put out will have a notation on there saying that diffusers or any kind of pressure changing apparatus, if you will, that's in the kitchen needs to be at least 10 feet away from the hood. Why? Because we don't want to create those cross drafts that would potentially pull smoke or heat from underneath the hood. And so again, as engineers, we know you guys have to introduce air conditioning in the kitchen. But an option that we have available, if you have to have air conditioning, or if you're looking to condition the air immediately around the hood space, is our split plenum, which basically adds an additional plenum for air conditioning right there around the immediate air of this area of the hood system. So again, there's no need for a four-way diffuser. You can use this dual plenum where we're still introducing outside air for the kitchen hood, but also introducing air conditioning far away enough from the hood so that we're still conditioning the space. All right, so now we've talked about how to integrate air into the actual hood. The makeup air unit is also obviously an important decision for us as well. Depending on where the job is located, we do jobs all over the nation. So depending on whether or not we're doing a job in Chicago or whether or not we're doing a job in Florida or California, we're going to try to promote the idea of heating and cooling, obviously depending on where it's located. And we do have various options for that. As you can see going left to right, we can do an untempered fan where we're bringing outside air directly into the space. We can do gas-fired or electric heating, depending on if the building has gas or not. But direct gas and indirect are probably our most chosen option just due to efficiencies. But we also have options for cooling as well, which we'll certainly talk about. Now, I want to look at the code again because often people would ask us, especially on the food service side, when do I need to heat and cool outside of the preference of the customer? Well, if you look at 508.1.1, there has always been this note in there saying that anytime the incoming temperature is 10 degrees different than the temperature in the space, you need to temper the air. The question is, what does temper actually mean, right? So I think as engineers, they kind of leave that interpretation up to you all. I can say that I think there are very few locations where local inspectors are requiring or forcing tempering of air other than, northern areas like I think New York and Chicago. But I can speak for Georgia. I've never had an inspector or for that matter, a fire marshal come to me or the mechanical contractor or another engineer and say, you have to temper the air based on code. And the reason being is there used to be an exception inside the code that said, as long as it does not create discomfort inside the kitchen space. And of course, that's always left up to the person who is either purchasing the equipment or who's working in the kitchen. And they often don't have a voice during the design process. So again, I don't think that anytime soon that the local inspectors in Georgia will ever enforce this. But as engineers, I know we always try to put our best foot forward by recommending heating and cooling depending on the application. So again, this code in itself is one of those reasons why I think we're starting to see that more frequently is because more engineers are saying, if I'm going to meet code, I've got to follow this requirement of either heating or tempering or conditioning rather, the makeup air coming inside the space. So again, untempered air is our base, but we do have heating and cooling, various options. If you don't even have gas or electric on the site or the capability to use either one of those, we do have hot water and chill water available. Again, gas is typically the most preferred option just because of the efficiency. As you can see, the combustion rate is 90%, 92% efficient. So even though you can smell a faint amount of gas coming into the building, keep in mind you're exhausting a good percentage of that air. So it is allowed to be used because, again, we're not mixing a lot of that gas into the kitchen itself, unlike a military quarters or sleeping quarters, rather, where you're pumping gas into a space. In that case, we would normally recommend indirect fired. Now, since we're talking about these units, we do have a proprietary damper that allows us when we're using demand control ventilation, which we'll talk about in a few minutes. But if we're using demand control ventilation, it allows us to reduce down to 50%. And I know some of our competitors will say we can reduce the airflow as well, 50% through a VFD. Well, most VFDs can do that. That's correct. However, the limitation is most of their makeup air units, if they're gas fired, cannot maintain a flame if they're going below a certain percentage because they don't have enough air moving across the burner. So again, our proprietary damper here, what it does is opens and closes based on the airflow. Based on the airflow, so that we're maintaining the right pressure across that burner to ensure that we are getting flame. And again, that is something that only we offer. So we are able to use our DCV and reduce it from the typical 80% application down to 50%. Since we're talking about makeup air, one of the big things that has come up since 2025 or even late 2024 has been the refrigeration change. And I'm sure you guys have seen this in other units outside of kitchen ventilation. But for those who are not aware, the EPA has certainly mandated in 2025 that anything manufactured in this year basically has to have the new refrigerant, which is 454B. So no longer can we manufacture anything with the 410 refrigerant. Same way we had this issue a few years back with R22. So as the EPA has mandated that, we've seen a transition in the industry where basically we're focusing on this new refrigerant that is, as you can see, A2L. It is a little bit more flammable, not to say that it's dangerous, but there's some competitors out there that are saying, well, you can't use direct gas firing with cooling because of the new refrigerant because it is flammable and basically a fire hazard. Well, that's not true. And if anybody who has concerns about A2L or this new 454, keep in mind, we've been using this same style refrigerant in cars. So, I mean, it's not like it's anything new. It's certainly been something that we've seen in other parts of the industry. It just happens to be new in this application. So the myth is, like I said, that you can't do direct gas fired with the new refrigerant. And some other, like I said, our competitors are starting to say that, but that is truly not the case. As of now, we are the only manufacturer that offers a PDX or packaged cooling unit that does have direct gas fired heating as well as the new refrigerant for our cooling coil. So again, if you have an application, application where you're potentially being forced into a DOAS unit because they're not offering a package unit like this anymore, certainly we'd love to take that opportunity and give you something that the customer can use for a specific application. Just a couple things about the new PDX unit that started shipping this year. It is UL compliant. And as you can see here, some of the parameters that we have, we can do anywhere between 800 to 5,000 CFM. And that is, of course, a limitation for certain applications. But as we were talking about a little bit earlier, normally for your applications that are above 5,000 CFM, your average hood size is a little bit over 25 feet, which in most applications, you would need a secondary makeup air fan as well. Or if you do have a larger hood, you may want to consider looking at a DOAS unit for that application, only because you have so much outside air being pumped into the space. It may just be better just to kind of package that instead of doing a rooftop unit and a PDX unit. So this unit is available between 3 up to 10 tons. And one of the newer things that we're offering is the fact that we have a 3 and 5 ton unit that is single phase, whereas before we did not have that capability. Here's a better look at it. Basically, we have our heating element upstream of the coil just in case there's any refrigeration leaks. And we do have all, because it's UL listed, of course, we do have all the safety factors on there with sensors and monitors that essentially if there is truly a refrigeration leak, the blower does go into extreme mode, pumps all of the air out of the unit. And of course, there are sensors on there that would shut the unit down in the event that there are some other leaks on the unit. So again, the reason why it's UL listed is because it has gone through proper testing to meet those requirements. What you'll notice most importantly is that we went from our old PDX to the new PDX is that the condensers are no longer on the side. And now they are mounted on top with our micro channel coils, which does make our unit a little bit more efficient, that has a greater delta T. Previously, where we're seeing our selections now, we were in a 10-ton unit. Now we're able to go down to about an 8-ton unit because those micro channel coils are so much more efficient. So again, what we're seeing out of this unit is a lot better output than we've seen even against our competitors, where, as we've seen in most of their previous applications, sorry, I thought I had a slide there. Their previous applications, they're starting to cool at 85 degrees outside. We're actually starting to cool at 75. So we're giving the customer greater comfort when it comes to air coming out of that front plenum. But keep in mind, the PDX is not solely used for conditioning the space. This is mainly being used to take the edge off the heat that's coming in during the summertime. So we're normally getting between a 15 and 20 degree differential between the temperature outside versus, of course, our dedicated outdoor air system, or DOAS as we'll refer to it as, which is simply used for comfortability. And I kind of want to start the conversation here as well. Obviously, our DOAS unit has now conformed with the new refrigerant as well with the 454B. But there's been a shift in the industry, I think, in the last probably 8 years, where now we're considering how do we increase the comfort level inside the kitchen. And again, I came into the industry in 2005, where the expectation was you're going to have 80, 85 degree temperatures inside the kitchen. We're working with some engineers and some national accounts now that the expectation is now we need 75 degree or less degrees inside the kitchen, which again is a big shift from where we were before. Not to mention post-COVID, the conversation about indoor air quality has been present as well. So I think DOAS came in at a time where it's kind of like a perfect storm, if you will, right? It gives us an opportunity to bring in fresh air, completely fresh air into the space and recirculate it, but it also comes at a cost. And I think there's been a little bit of confusion as to when to use it, when not to use it. For those who don't know, we've made DOAS units with energy recovery systems for years before our competitors made it. But I think they made it a big push in the industry to make sure that when we do focus on kitchen ventilation, we have the best of both worlds. So what I want to kind of focus on is not necessarily the application itself, but how do we use a DOAS and when do we use a DOAS? Because again, there are certain applications that it's preferred, but I think our competitors are starting to push it so much that they want to make it a standard in kitchen ventilation when in most cases it's not necessary. So I have 4 different scenarios here. Again, the most common one is our traditional system where we have a dedicated makeup air unit that's pumping air through the hood system. And then we still have our standard rooftop units pumping air as well and recirculating air for the air conditioning in the kitchen. And of course, the dining room, we still have the rooftop unit. Going to the right, and I'm going to go clockwise, the new traditional system that we're starting to see being pushed in the market is using a DOAS unit, right? And basically using that for the hood as well as still using a rooftop unit. And in some applications, like I said, that doesn't really make sense, especially if you're going to be using it with a front plenum where you're going to be exhausting a lot of the air. So again, going back to my conversation about the PDX, where we're looking at 70 degree discharges for outside air, your DOAS is normally discharging at 55 degrees. To me, it doesn't make sense for us to dump 55 degree air through a front plenum if we know the majority of that air is going back out through the hood. Going to the bottom right corner, then we have a fresh air restaurant where we're actually using DOAS for the front of house as well as back of house. And then of course, the last one on the bottom left would be where we're using a DOAS unit for just the entire front of house, but then using a traditional rooftop unit for the back of house for your dining room. So the question is, when do you use it? So I would happen believe that in most applications, we want to use a DOAS when you have an open concept, right? Your kitchen is completely exposed to a dining room, so you're having to recirculate or pump in a lot of outside air to the space. If you're trying to keep comfort in the front of the mind of the customer, you certainly want to look at using a DOAS unit. Food halls are the same situation where you have a lot of open vendor space, so you're needing a lot of outside air, not only for the entire food hall, but for each individual space. Teaching kitchens would be another great application. One thing that's not on here would be a ghost kitchen. Ghost kitchens became very prominent during the COVID era, where food was being cooked off site and companies like Uber Eats and Grubhub were picking up food and delivering to people. And so basically they were using that as a kitchen versus having to take up the kitchen staff at a traditional restaurant. So they have multiple stations at these ghost kitchens and they can serve multiple restaurants or send food out from multiple restaurants from one location. So ghost kitchens are almost like food halls in the sense that you're pumping a lot of outside air in the space. You don't know exactly which hoods are on and off. So a DOAS would be a great application for that. And of course, small footprints, Huddle House, Waffle House, Crystals. These are really small footprints that don't have a lot of square footage. And again, in most cases, you have an open kitchen that is sharing the same space or at least exposed to the same space of the dining hall. When do we use makeup air? Well, I think if you're talking about existing conditions, it takes a lot to kind of transition into a DOAS unit where now you're considering a much heavier unit. So now you got to go do some structural engineering to verify whether or not that unit will not only fit on the roof, but can the roof maintain the weight of it. So normally we would recommend doing a makeup air unit if it's a true one-to-one replacement. If you already have existing rooftop units, that's another great application where you're kind of stuck with what's already there. Most what they call white box applications, they've already installed rooftop units there. So to go back and redesign the entire job is a little bit difficult. So we would recommend doing a PDX design there. And of course, like I said, if you have separate area spaces for your kitchen and your dining room, because again, you don't have any transfer air in most cases going from the dining room into the kitchen. So we're going to recommend doing a dedicated makeup air unit or a PDX rather with a traditional rooftop unit. And as we said, food halls can be a little bit tricky depending on how they're designed. So there may be an option to do either one there. But for certainly new designs, if we can implement a DOAS early, that's certainly when we want to start the conversation. But again, it's all going to be dictated on whether or not there is that separate space or not. We talked about ghost kitchens, and of course, if the customer is really concerned or maybe have multiple locations and they're really concerned about comfort cooling, obviously the DOAS is the best, right? So if they're willing to spend the money to do it, that's something that we certainly can appease them on. One of the great things I love about this company, and as I said, I worked for a previous company, we tend to focus on the solution, right? We want to give the customer as many options as possible so that they can make a sound decision on what they want, not necessarily what we want them to have, but what they really need based on the information that they give us. We listen to our customers, and based on the information they give us, we give them options in order to make sure that they're satisfied with the solution that we're giving them. Once we determine our fans, the last component that we really look at would be our kitchen control systems. And this has been pretty standard, I think, in the market for almost 15, 20 years now, where basically we're looking at, do we want a standard constant volume package or do we need a variable volume package? I know prior to 2010, I know LEED certifications and things like that where energy conservation was really important. A lot of those certification points came from, did you have a demand control or a variable volume package included in your hood system? And so we saw the growth of that. But now, not only is it beneficial for energy conservation, but we're starting to see that some of the companies like Georgia Power are offering rebates, obviously, to incentivize some of the customers who are either transitioning their kitchens to a modern kitchen or building brand new kitchens, where we see now they're offering $500 per horsepower to, again, incentivize that individual to go to the demand control ventilation application. IMC does allow for demand control ventilation. It's one of those things that the concern up front was back in the day was, hey, how do we maintain 1,500 feet per minute of velocity in the duct? Well, NFPA had already said you can drop it to 500. And of course, then they went back and they said, look, we will allow it during low cooking or non-cooking periods. The Energy Conservation Code also kind of pushes this idea by saying, look, if you have 5,000 CFM or more, well, we recommend that you have some type of demand control ventilation as well. So that's usually kind of our standard, or if you want to use it as a rule of thumb, if we know we have a customer that's building a restaurant that's doing breakfast, lunch, and dinner, we know there's going to be at least 2 low periods throughout the day. So it would be beneficial for them to use demand control ventilation to save some of that energy cost during those low cooking periods. And not to mention that pricing on these components, whether it's the VFDs, the heat sensors, they've all come down considerably since the day of early 2000s, where Malink had kind of introduced this into the market. So we're starting to see this kind of standardized in a lot of chain account work. But again, it's really the customer that makes the decision on whether or not they want to go this route, or from your perspective, if you need reduction in airflows to kind of minimize your HVAC, that's something that we can look at as well. As I pointed out, these are just some basic pictures of the actual touchscreen that comes with these new next generation controls. Everything's pretty intuitive. Instead of these toggle switches that can break from time to time, we've gone to just like our phones, right? Digital touchscreens. And so the customers on site or staff can navigate through the menus just by a touch of a button, whether it's getting into settings and changing some of the parameters, or simply just turning the hood lights on and off, as well as the fans. As I pointed out before, we do have a 50% turn down versus some of our competitors that can only turn down 20%, so that the fans are running at 80%. And that's mainly due to our proprietary damper that's built into our makeup air fans, especially our heated makeup air fans specifically. So the general idea, like I pointed out, just a chart representation of what I talked about. You see your low cooking periods between breakfast and lunch, and of course lunch and dinner, where you could be saving energy versus using a constant volume system that would run at the exact same rate all day long. Some other benefits that we have when it comes to DCV, as we call it, or demand control ventilation, prolonged life of the equipment. For those who are not familiar with how VFDs work, or variable frequency drives that we use, basically there's a slow ramp process versus a traditional system, where when you turn the hood system on, it essentially goes from 0 to 60 hertz and puts a strain on the fan because, again, that torque that is on usually the belt of the motor. With the slow ramp, like I said, you're not putting as much of a burden on that motor, and that does it eventually extend the life of the fan itself. Not to mention, if anybody's ever done test and balance, I know Felipe and myself have been in the field quite a few times. It's a lot easier to test and balance a fan, test and balance a fan in a hood system inside the kitchen versus having to get on the ladder and get on the roof and actually have to do it on the roof. So another great benefit of using DCV or VFDs in general. And I kind of talked about the energy rebates that not only are we offering here in Georgia, but Florida, California, places like that. That's the last of it. I do want to kind of talk about just some other items that we can jump into later on if you guys need us to, want to do a separate lunch and learn or a visitation. We do offer prefab grease duct through a partnership with a company called Jeremiah's, which is based here in the Atlanta area. So if you have any jobs that you want to specify prefab grease duct, we do have CAD details that we can include in our information to illustrate that that is a recommendation. As you all know, prefab grease duct takes a lot of the liability out of the contractor because we're not doing any infield wiring. I'm sorry, infield welding rather. And so again, we know that these products are tested at the manufacturing facility, so it limits the amount of issues that they have as far as pinholes or leaks in the grease duct because we know it's been manufactured and tested. We do offer pollution control units. I don't know how much work you guys are doing downtown or in areas where you have high rises and residential applications where they don't want to have to smell the food from the restaurant below them. We do offer a couple of options for pollution control to minimize smoke and odor. And lastly, we do offer a residential hood. So if you have a commercial building, whether it's a dorm, a fire station, daycare, these are applications where they may have a residential appliance. Most fire marshals or inspectors are going to require that they have a hood with fire suppression system. And of course, that's where the fire ready or residential hood that we offer would come into play. So that is something that we do offer. And most engineers are not aware of that. They only look at Brown, but it would be a comparable product to what they offer as well. With that being said, I mentioned we do AutoCAD, Revit drawings. We do job site visits, obviously in-person lunch and learns. We're here to serve you. Again, our job is to make your job a lot easier. So we want you to rely on us for that information, specification, things like that, to make your job easier so that you don't have to worry about kitchen ventilation questions and concerns. With that being said, if there are any questions, we'll open it up for that.
Edwin, so